In this video, we're going to look at a problem called graphing games and rides. We have the equation 2.50x plus y equals 15, and it represents the relationship between the number of games, which is x, and the number of rides, which is y, if a student is spending $15 on rides and games at an amusement park. So each game costs $2.50. So we multiply the number of games played by 250. Each ride costs $1, so we're multiplying the number of rides by 1. We're adding those two things together to get the total amount of money spent, which is $15. So the first question says, what's the number of rides the student could get on if they don't play any games? Or in other words, if x is 0. So we would figure that out by plugging in 0 for x. So that would give us 2.50 times 0 plus y equals 15. And then we would solve this equation for y. We know that anything times 0 is 0. So we have 0 plus y equals 15, or in other words, just y equals 15. So this tells us that if the student did not play any games, they could go on 15 rides. The second question is, what's the number of games the student could play if they don't get on any rides? We would figure this out by plugging in 0 for y and then solving the equation for x. So my equation would be 2.50x plus 0 equals 15. Or in other words, 2.50x equals 15, which we would solve by dividing both sides of the equation by 2.50. And if we do that, we would get x equals 6. So that means that the student could play 6 games if they did not go on any rides. The third question says to go to Desmos.com and graph the line by typing the equation above into a blank row in the left column. So our equation is 2.50x plus y equals 15. So I go to Desmos.com and then click on the graphing calculator. I'm going to type my equation in this box. So there's the line. Now I can't see all of the line in the viewing window, but remember what you can do is click on this wrench right here, and that will allow you to change the viewing window. Or you can zoom in and out by clicking the plus and minus button. So I'm going to change my viewing window here. So there's my graph. Notice that this graph has a y-intercept at 15 and an x-intercept at 6. So the next part of the question says to type the coordinates of the x-intercept and the y-intercept to mark the points on the graph. So the coordinates of my x-intercept are 6, 0. And the coordinates of my y-intercept are 0, 15. And those points correspond with the answers that I found to questions 1 and 2. If the student doesn't play any games, that would correspond to the y-intercept of 0, 15. Remember that the x-coordinate is number of games and the y-coordinate is number of rides. The answer to question 2, if they didn't get on any rides, they could play 6 games, corresponds to the point on the line of 6, 0, or the x-intercept. And then the last part of this question is telling me to copy and paste the link to my graph. So remember, when you're on the Desmos website, in order to do that, what you want to do is click on this box with the arrow in it that says Share Graph. Then you will copy the link by clicking on Copy, and then go to your Word document and paste the link. Now, I'm doing this in OneNote, which is why my links always convert automatically to an image of the graph. If you're doing this in Word, that won't happen for you. You'll just see a regular hyperlink, and that is totally fine. Question 4 says, what is the slope of the line? So we're going to calculate the slope using our slope formula, which, as you recall, is m equals y2 minus y1 over x2 minus x1. And we have the 2 points that we identified the x and y intercept of 0, 15 and 6, 0. So if we label these points as x1, y1 and x2, y2, and then plug into the slope formula, we get 0 minus 15 over 6 minus 0, which is negative 15 over 6, which we can simplify to negative 5 over 2 if we want to keep it as a fraction, or negative 2.5 if we want to write it as a decimal. Note that the line is going downward in the graph, and so we would expect that our slope would be negative. And in fact, that is what we found. Question 5 says to rearrange the equation to solve for y. So my equation, going back up here, was 2.50x plus y equals 15. Now we want to get y by itself. The way that we would do that is by moving the 2.50x to the other side. This is similar to how we would solve an equation for y, but the big difference here is that we're not getting a single number for y. Instead, we're getting a formula. So I'm going to have y equals 15 minus 2.50x, or I could write it as y equals negative 2.50x plus 15. Or instead of 2.5, I could use the negative 5/2 that I calculated earlier. Remember that when we're writing these equations, we're looking at the slope and y-intercept when we have y by itself on one side. So looking at this equation, what I notice is that the negative 2.5 is the slope and the 15 is the y-intercept. So looking at my graph one more time, I see the y-intercept pretty clearly is the point 0, 15, or that 15 is the y-intercept. And then if I look here, I should see that for each unit you go 1 to the right, you're going down 2.5 units. Or you can see that you're going down 5 units as you go to the right 2 units, which gives you the slope of 5 over 2. So those are the connections that you should see between the equation and the graph. When it's in y equals mx plus b form, you have the slope m and you have the y-intercept b.